At the core of our product, we offer a framework for establishing identity in kind of a zero trust environment. So passwords are something called a symmetric secret. There's a piece of information that you have to remember, and that some service or third party remembers that same piece of information. And this is ultimately how you prove you are who you say you are to get access to that service. Now, the problem with a shared secret or a symmetric secret is when someone can access the collection of those from the service provider or the backend database, they can then pretend to be you. So at the core of our product, we offer a framework for establishing identity in kind of a zero trust environment. And the way that we do that is with an asymmetric secret. So an asymmetric secret, it's actually not a new technology. It was invented in the 70s. And it lets us do things to where we can create a pair of information. A piece of information that you keep secret, and you have to share it with no one. Now remember, with the symmetric secret, you had to share it with one person. With an asymmetric secret, you share the secret part with no one. And then there's a non-secret part, a public part, and you can share that with the world. And what these two things allow you to do is when you want to prove you are who you say you are to a third party, they'll challenge you by saying, prove your identity. And you can use that secret to add a signature. Now, it's a special type of signature, it's called a digital signature, but it's a way of encrypting a piece of information using your secret that you've shared with no one. And then you give that back to the service provider, and they can actually verify it with the public part or the non-secret that you shared earlier. So that's kind of a very high-level description of something called asymmetric cryptography, and it forms the basis for actually digital signatures. So why doesn't this happen 30 years ago? Really, we'll say 25 years ago-ish. We do take advantage of some more recent and modern technology that's been introduced in the last couple of years in terms of mainstream computing devices that helps ensure a level of security in the solution. And what that is modern chips now have something called TPMs and secure enclaves, where there are these really nice properties where you can generate some of those asymmetric secrets that we were talking about earlier, right? The private key with a public key. And the way this hardware is constructed, the private key physically can't be moved off the device, right? So it fundamentally becomes immovable. And that's really nice because it gives us one of those properties where if the thing that is secret can't move, then it can't really be disclosed, right? It can only be used by someone who controls that device. And that really kind of forms the basis. And then the final bit really is the prevalence of SSOs. So secure sign-on is a technology and a tool that companies have been using to aggregate the authentication points for their users to get access to their applications. So leveraging these, a new protocol called OpenID Connect, we're able to kind of work with existing SSO solutions. We don't really require our customers to change any infrastructure. We don't require them to write any code. We're going to reduce friction on your users. We're going to improve the overall security experience. We're going to let you start making risk-based decisions on how you not just authenticate but authorize users to an application. So when you authenticate, what is the posture of your device? What is the risk of the thing you're actually trying to access? And should we allow that in a moment in time? So we can do all of that, and I can get it set up in your environment with about 10 minutes with your identity engineer. So it's easy to try. It provides value to the identity engineers or the IT staff, as well as the end users. Why don't you try it out? It'll take 10 minutes, and I guarantee you won't turn it off.